Today's bell ringer wiki that the kids are working on has to do with the practical application of congruent and right triangles. And some of the common core standards that we're working on are the theorems involving the similarity and being able to define trigonometric ratios, and also being able to apply those to things in our surroundings. Previous knowledge that the students have is they've been working with plane transformations, constructing two-dimensional geometric objects, properties of right triangles, and the students have also learned the length of their stride and the length of their shoe, along with hand width and a few other things that are just neat tools to have measurement when you don't have a tape measure or a yardstick. Some of the knowledge gaps that we had to overcome for this particular lesson. Originally it was designed for the outdoors, for being able to use what you know about congruent and right triangles and be able to measure distances or widths of things that you can't get across, let's say a stream or a river. And we had an opportune time now that we actually, outside of the school, we had a water main break. Kids can't get into their half-court basketball and field, and the city has offered to build us another half court while they work on that one, only it's going to be a long time that they're working on it. So the problem that we came up with was, in the neighborhood, the half court has been fenced off for underground water main break repairs, as I just said, and the city's offered to rebuild it. Only because of the safety hazard, they've fenced it off, and they can't get in there to measure it to see what they can do to make another half court, because they want to take advantage of this. Instead of just making a separate half court, they want to make a half court field that matches the original one, so they have a full court when we're done. So the challenge is, what would you use what you know about congruent and right triangles to solve this problem without being able to actually get in and measure where the hoop is in the old court? So class, have you had long enough to work on this problem? You think we're ready for the solution?
Yes, Mr. Karakoff.
All right. Our solution to this is, as you know, here's the basketball hoop that we couldn't get to. Here's the fence where the city has fenced it off, and we're stuck over here on this side with the new court they're going to give us. But we don't know what this distance is to this hoop. So what we're able to do is use what we know about congruent, similar, and right triangles to be able to step this off and come up with a distance to where this hoop is and the center of this, so that when we're done we can have a full half court. What you would do is you would walk along the fence until you're right in front of that basketball hoop. You would turn 90 degrees to your left. You would walk 25 paces, and you put your basketball down in that spot. You would then walk another 25 paces. At that point, you would turn left again, 90 degrees, and then you would continue to walk along this line, this D to E line, until you were able to sight across the basketball and line it up with the hoop. At this point, you would be at the opposing congruent angle, and then you would know the actual distance that you are from that fence to this hoop, and this would be the matching one. You would then turn again 90 degrees. You would walk 50 paces, which is double what you walked right here, and that would put you exactly where your hoop is. And now you would know where to put the hoop. You would know the dimensions you need for your complete half court, and when you were done, you would have a complete full court. In thinking of this, in this problem, is there another way we can solve this? Yes, there is. It's the Pythagorean theorem, which is going to be in today's lesson, and we'll get to find out how to solve that.